All right, so um, we're going to take a deep dive into this multiomics thing. You sent over some really interesting stuff, especially this ARK Invest report, Big Ideas 2025. They're predicting some pretty big changes in healthcare thanks to multiomics, it seems like.
Well, it seems like we've been looking at biology the wrong way for a long time, like we only had a few pieces of the puzzle before. But now with multiomics, we can finally see the whole picture.
Yeah, that's a great way to think about it. Instead of just looking at one aspect of your biology, like your genes, multiomics lets us analyze all these different layers of information, your DNA, RNA, proteins, metabolites, so we can get a more holistic view of your health.
Okay, I'm following you. So give me a breakdown. What exactly are we learning from each of these layers? Because the report mentions genomics, transcriptomics, proteomics. It's kind of a lot to keep track of.
Well, think of it like a cake with multiple layers. Each layer has a different flavor and texture, right? Genomics is the base layer, your DNA. It's the blueprint that makes you you.
Okay, so that's our foundation. Right. Then we have transcriptomics, which looks at your RNA. You can think of it like a messenger, carrying instructions from your DNA to build proteins.
Got it. So DNA is like the blueprint and RNA is the construction worker.
Precisely. Then you have proteomics, which analyzes the actual proteins themselves. These are the workhorses of your cells. They carry out all sorts of important functions.
And then the last layer.
Metabolomics. This is the study of small molecules involved in your metabolism. Basically all the chemical processes that keep you alive.
So each layer gives us a different piece of the puzzle. And when we put them all together, we get a much more complete picture of what's happening in the body.
Exactly. And what's really exciting is that the cost of analyzing all this data is going down rapidly. Do you remember the Human Genome Project? It took over a decade and billions of dollars to sequence one human genome.
Yeah, I remember hearing about that. It was a huge deal at the time.
It was. But today, thanks to new technologies, like Illumina's high-density flow cell sequencing, we can sequence a genome in just hours for less than $1,000.
Wow, that's amazing. The report actually mentions that. Costs are falling faster than Moore's law.
It's pretty incredible, right? And then there's Twist Bioscience. They're doing some amazing things with silicon-based DNA synthesis.
Yeah, what's so special about their approach?
Well, they've essentially miniaturized the process of building DNA. They use these tiny silicon chips, like the ones in computers, to synthesize DNA strands in a massively parallel way.
So it's like they're printing out DNA.
It's kind of like that, yeah. And this makes it way cheaper and faster than traditional methods.
So we're talking about reading and writing DNA at a scale and speed we've never seen before. But what does this all mean for healthcare? What are the real-world applications?
One of the most promising areas is early cancer detection. Imagine a simple blood test that could detect cancer cells years before they'd show up in a traditional scan.
Wow, so we're talking about catching cancer before it even really develops.
That's the idea. It's called minimal residual disease testing, or MRD testing, and it's like a super sensitive radar for cancer cells.
That's pretty mind-blowing. But the report also mentions that MRD testing could generate a massive amount of data, even more than the UK Biobank, which was this huge genomics project.
Yeah, that's true. But this data explosion is actually a good thing, because it lets us build more accurate predictive models, which means earlier diagnoses and more personalized treatments.
So even though it's a lot of information to process, it ultimately leads to better outcomes for patients.
Absolutely. For example, if we can detect cancer recurrence early on, we can intervene with targeted therapies before the disease has a chance to spread.
Okay, I'm starting to see how this all connects. But the report also talks up some other pretty futuristic stuff like virtual cells and self-driving labs. Can you break those down for me?
Sure. So virtual cells are basically digital simulations of human cells. It allows researchers to test out different drug interactions in a computer without having to do physical experiments.
So it's like a video game for scientists.
It's kind of like that, yeah. But it's a really powerful tool for drug discovery because you can test thousands of different combinations very quickly.
That makes sense.
Yeah.
And what about these self-driving labs?
Well, imagine a lab where robots do all the experiments. They collect data, analyze results, all guided by artificial intelligence. There's a company called Recursion Pharmaceuticals. They're leading the way in this area. They've actually built a self-driving lab that combines multi-omics, automation, and AI.
So it's like a fully automated drug discovery factory.
You could say that, yeah.
Sounds like something out of a science fiction movie.
It does, but it's becoming a reality.
And the report says this could significantly reduce the time and cost of developing new drugs.
Exactly. They estimate that AI-driven drug development could shorten the time to market by almost 40%. and reduce costs dramatically.
That's huge. So this means patients get access to new treatments faster.
Right, and it could also mean higher returns on investment for pharmaceutical companies.
Which brings us to another interesting point. The report claims that cures could be 20 times more valuable than a typical drug. That's a pretty bold statement.
It is, but think about it. The cost of treating a chronic disease over a lifetime compared to a one-time cure. The economics are pretty clear.
I see your point. A cure eliminates the need for ongoing treatment, which can be expensive and often comes with side effects. But is it really feasible to cure diseases? Or is that just wishful thinking?
Well, multiomics is giving us a much deeper understanding of disease mechanisms, and that's essential for developing cures.
So we're not just treating symptoms anymore. We're actually targeting the root cause of the disease.
Exactly. And in some cases, that could lead to complete eradication of the disease.
Wow, that's a pretty profound shift in perspective.
It is, and it's likely to have major implications for the pharmaceutical industry. Companies that embrace these new technologies and invest in multiomics-driven drug development, they'll be the ones who thrive in this new era of healthcare.
So it's like survival of the fittest. But for pharmaceutical companies,
You could say that.
this is all incredibly exciting. But I imagine there are also some ethical considerations with this level of biological insight.
Of course, with any powerful technology, we have to be mindful of the ethical implications. We need to make sure that these advancements benefit all of humanity and don't exacerbate existing inequalities.
That's a really important point. This deep dive has given me a lot to think about. It seems like multiomics isn't just changing healthcare. It's changing how we understand ourselves as human beings.
I think you're right. It's giving us a whole new level of insight into the complexity and interconnectedness of life.
It really is fascinating.
Well-
And I'm eager to see where this all leads in the years to come.
And it's not just about, understanding ourselves better. It's about how this impacts healthcare as a whole.
When you say as a whole, what do you mean exactly?
Well, think about how our healthcare system works now. It's pretty reactive, right? We basically wait until someone gets sick, and then we try to treat their symptoms.
Yeah, I see what you mean. It's like we're always one step behind.
That's exactly it. But with multiomics, we can finally shift to a more proactive approach. By analyzing all this biological data, we can start to identify patterns and predict who's more likely to develop certain diseases.
So instead of waiting for people to get sick, we could actually intervene early and prevent the disease from developing in the first place.
Exactly. It's like having a personalized health forecast. By understanding your individual biology, we can give you tailored recommendations to optimize your health and reduce your risk of disease.
That sounds incredible, like truly personalized healthcare.
It is. And it's not just about prevention either. Multiomics is also changing how we diagnose and treat diseases.
You mentioned earlier how MRD testing can help detect cancer earlier. Are there other examples? Can this be applied to other diseases too?
Absolutely. The report highlights a bunch of examples. Like in Alzheimer's disease, for instance, multiomics is being used to find biomarkers that can predict how the disease will progress, and that can help us develop new therapies.
So even for complex diseases like Alzheimer's, where we still don't fully understand what causes them, multiomics can give us valuable insights.
Exactly. It's helping us put the pieces of the puzzle together so we can develop more targeted and effective treatments.
So it sounds like multiomics is really ushering in a new era of healthcare, one that's focused on prevention, personalization, and precision medicine.
That's a great way to put it. And as the cost of analyzing this data continues to drop, these advancements will become accessible to more and more people around the world.
That's encouraging. It would be amazing to see everyone benefit from this.
Definitely. The democratization of healthcare is a really important part of this technological revolution.
This deep dive has been really insightful. I'm really starting to grasp the potential of multiomics.
It's a fascinating field, and we've only just scratched the surface. There's so much more to explore and discover. And it goes beyond just treating diseases, too. Multiomics is changing how we think about wellness and longevity.
That's interesting. So you're saying it's not just about living longer, but living healthier for longer?
Yeah, exactly. By really understanding our biology at a deeper level, we can make better choices about things like diet, exercise, lifestyle, all to really optimize our health span.
Health span versus lifespan.
Yeah.
I like that. So it's not about just adding years to your life, but adding life to your years.
Exactly. And multiomics can help pinpoint the things that contribute to healthy aging, so we can create really personalized interventions to help people stay healthy throughout their lives.
It sounds like multiomics is really shifting things, moving away from just managing diseases. and towards actually optimizing our health.
That's right. It's about empowering people to take control of their health and make choices that support their well-being long-term.
This whole deep dive has been a real eye-opener. Multiomics is such a game changer. It has the potential to revolutionize healthcare and so much more.
I agree. It's a really exciting time to be working in this field. I can't wait to see how it all unfolds in the coming years.
It feels like we're right on the edge of a new era of healthcare. More personalized, more predictive, and way more proactive.
Absolutely. And it's not just limited to healthcare either. Multiomics could have a huge impact on other fields too, like agriculture and environmental science.
Wow, the ripple effects are pretty incredible.
They really are. And as we keep learning more about the complexities of biology, I have no doubt that multiomics will lead to even more groundbreaking discoveries.
Well, this has been an amazing journey into the world of multiomics. And
Yeah.
I'm definitely feeling optimistic about the future of healthcare and our ability to improve human health and well-being.
It's a time full of promise and possibility for sure, and I believe that multiomics will play a major role in creating a healthier future for everyone.
Well, thank you so much for sharing your expertise with me today. It's been truly enlightening.
The pleasure was all mine. And to everyone listening out there, I encourage you to stay curious about these advancements as they continue to develop.
That's great advice. And to all our listeners, thank you for joining us on this deep dive into the world of multiomics. Until next time.